Hello everyone, welcome to my channel. You are learning with Dr. Shobha Nikam. In this video, I'll talk about path sensitization in design for testability. So let's first understand what design for testability means. What do you think? What is design for testability? Testability means ability to test chips. So design for testability means we must design our chips or our circuit in such a way that we can easily test them after fabrication. So while designing circuitry, we must take care about testing of the circuit. But why it is required? Why DFT is required? Why design for testability is required? Because chips are very complex. You know that millions of transistors are present in single tiny chip, and internal nodes are not directly accessible for testing. Like, see, if I have millions of transistors present in chip, I can only test primary transistors directly, but I can apply external inputs to primary transistors which are at the input side. But what about the gates or the transistors which are present at the center? So for that, we must design our circuit in such a way that observability is maximum, controllability is maximum. Observability means ability to observe each and every node in the chip, and controllability means ability to control or ability to set them to 1 or 0. So which faults are present in chip? So faults can be broken wires, shorts or opens, that is transistors are continuously shorted or they are continuously open, or stuck at faults. Stuck at fault means the pin is or input or gate terminal, drain terminal or source terminal is stuck to 0 or it is stuck to 1. I have prepared separate video about the stuck at faults. The link is given in the description box. So it is hard to control and observe signals deep inside the chip. So testing ensures that only good chips reach the customer. So it is necessary to test each and every chip before we deliver it to end customer. So advantages of DFT are DFT makes testing faster, cheaper and more effective. Then why do we need path sensitization? So it is one method of testing of the chip, or it is used for generation of test patterns. So in digital circuits, a fault may exist inside, but it's not directly visible at the output. Unless we design a special input pattern, the fault effect may get hidden or masked. So let's assume simple AND gate. In case of AND gate, when both inputs are 1, we get output 1. So if any input pin is stuck to 0, so what I'll do, I'll apply both inputs as 1, 1 and then I should get 1, but because one pin is stuck to 0 or shorted to 0, what I'll get at the output? 0. So that I can say the fault is present at the input pin, but because AND gate is single circuit or it is very small, I can directly control its inputs. But if I have an AND gate at the center and before AND gate, if I have thousands of other gates, then I need to make other inputs, or I need to connect primary inputs in such a way that to that particular AND gate which I am testing will receive inputs as 1 1, so that I'll check whether input is stuck to 0 or not. So it is the in case of path sensitization means I must check entire path which will set my inputs of AND gate to 1 or 0. See, we have one AND gate and before that AND gate I have many other gates. So I must track the path which will at the end set inputs of AND gate to 1. So for that, first is activation of fault and then propagation of fault. Without path sensitization, fault remains invisible, and with path sensitization, fault shows up at the output. Then see here, masking of fault means what? Suppose I have one AND gate. It has two inputs A and B. Let's say B input is stuck to 0. B input is stuck to 0. Say if I'll apply 1 1, I will get 0 and I'll say fault is present. But what if A is continuously receiving 0? If A is receiving 0, what I will assume? I am getting 0 at the output because my A is receiving 0. I will not check value of B. B is 1 or 0. A is 0 means I'll get 0. So here, even if B input is stuck to 0, it will not get reflected at the output side. And that is called as masking of the fault. So steps of path sensitization are, first is fault activation. Fault activation means if any pin is stuck to 0. If any pin is stuck to 0, what I'll do? I'll set it to 1. I'll push external 1 at that pin. If I am pushing 0 and it is internally shorted to 0, I won't be able to identify the fault. So what I'll do is, if pin is shorted to 0, I'll apply 1 to that pin. So here fault activation means apply input values such that the faulty node produces the opposite value. Then path sensitization means I will identify the path which is required to set that pin to 1 or 0, as I told you earlier. If I have an AND gate and before that AND gate if I have plenty of other gates, I'll track one path and I'll set all inputs in such a way that to that AND gate I can apply 1. Fault propagation is once the path is sensitized, the fault effect flows to the primary output or scan flip-flop. At this point, if faulty output is not equal to output of fault-free circuit, then fault is detected. If I am expecting 1 at the output, but if I am getting 0, it means fault is present in that path. See, we must be very careful about setting inputs of AND gates and OR gates. See, we can design digital circuits in sum of product form or in product of sum form. In both forms, what we need is AND gate and OR gate. So we must know what are the controlling inputs for AND gate and OR gate and what are non-controlling inputs for AND gate and OR gate. So see here, if I have AND gate, it has two inputs, A and B. If I wanted to identify fault present at input A, if I wanted to check if A is shorted to 1 or 0, then I must apply value at B which is non-controlling. It means it will not affect my output Y. Let's say in case of AND gate, if B is equals to 1, what is output Y? Y, if A is 0, Y is 0. If A is 1, Y is 1. So B is 1. That 1 is non-controlling input, whereas if I'll apply 0 at B, then directly my output will become 0 instead of checking value of A. So here for AND gate, the non-controlling, it means it should not control output Y. Output Y must be controlled by faulty node. 1 is non-controlling value, whereas 0 is controlling value. For OR gate, 1 is controlling value. It means for OR gate, if one input is 1, output is 1. Whereas 0 is non-controlling value. It means if one input B is 0, output will depend on value of A. If A is 0, output is 0. That is 0 plus 0 is 0. If A is 1, output is 1. So for AND gate, non-controlling value is 1 and for OR gate, non-controlling value is 0. So when we do path sensitization or when we use path sensitization method, we must always use non-controlling value at side inputs to keep the path open. So to check A, I'll apply non-controlling input at B. Here to check B, I'll apply non-controlling input at A. And for NAND and NOR, see, we can also design our digital circuits using universal gates, NAND and NOR. In that case, same rule, only just outputs are inverted. Now let's see, this is my circuit. See here, so fault excitation means here my node X is shorted to 1. So here stuck at 1, fault is present. So very first thing is, if stuck at 1 fault is present, what we do? We apply 0. We try to push opposite signal here. So when this is 0 or fault is present at input A, what I'll do? I'll apply non-controlling input at C. So non-controlling input for AND gate is 1. So C is equals to 1. So for this OR gate, to identify fault at this path, I must keep other two for OR gate. Non-controlling inputs are 0. So I want this 0. I want this also 0. So to get 0 here, see what I'm doing is I'm pushing or I'm setting A to 0. So A is equals to 0. C is 1. So here C is 1. It means to get 0 here, B must be 0. Are you getting what I'm saying? First, we'll see the gate where I'm going to find the fault. So I have two inputs here. Fault, I wanted to identify fault at input A. So what I'll do? I'll simply set another input. Here another input is C. So I will set this C to non-controlling value. So non-controlling value is 1. C is 1. Then stuck at 1 fault is present, so I'll apply A to 0. So A is 0, C is 1. Now let's find out value of B. So here C is 1, but what I want is I want output of this AND gate to be 0. Why I want it to be 0? Because 0 is non-controlling input for OR gate. So here I want other two inputs to be 0. So to get 0 here, C is 1. So B must be 0. So this is my test vector which I should apply here to find out the fault. So because this C is 1, here I am applying 0. So what this AND gate should generate? Because of this 0, it must generate 0. But this point X is shorted to 1 or stuck to 1 or shorted to VDD line. 1 means VDD. So here I'll get 1 and this OR gate will also generate 1 here. So what I will say, I can identify that this A is stuck to 1. A means this A is not stuck to 1. This pin is stuck to 1. So here I can be able to identify that. So see here, this D will come here, and because this is 1, if D is 0, output is 0. If it is 1, output is 1, and the same value will go here. So in case of path sensitization, again there are two types: forward path sensitization and backward path sensitization. Now let's see backward path sensitization. So this is backward propagation. So what I'll do, I'll first set this output to be D. I'm applying D here. Then to get D at the output, what should be the input? Input must be 0, 0 and D. To get D here, one pin must be 1 and then other pin is D. D can be 0 or 1. So that D will come here, then it will come here, and because other two inputs are 0, so I'll get output D. So it is backward propagation. So, path sensitization method is used in DFT in automatic test pattern generation for identification of fault, and we must test our chip before we deliver it to the customer. And when we design our chip, we should take care that chips are easily testable. So it was all about path sensitization method. I hope it will be useful to you. Thank you so much for watching my video, and don't forget to like, share and subscribe. Thank you so much.